Hello everyone and welcome to the final section in Chapter 7. This is Proportions in Triangles, Section 7.5. Let's get started. Here we have the side splitter theorem. Now the main principle of this is we have a triangle, as you can see. We have a triangle QYX or XQY, however you want to call it. And we have this as a given. RS is parallel to XY. Now, if we have these two lines parallel within this side, see how it's a side that's split with parallel lines, okay? See the side is split. Then we can say this. We can say the ratio of this part of the triangle to this part of the triangle, so the green to blue, is going to be the same ratio as this green section, the bottom part, to this top part also. Or if you would rather, the top part is proportional to the bottom part, okay? So I'll go ahead and write it that way. I like to think top to bottom. So we can say the top segment to the bottom segment proportion is going to be equal on both sides of the triangle. So let me go ahead and put this into segment notation. So we have QR over RX is going to be proportionate to QS over SY. And this is also true if you reverse it. So if you put the bottom on top, okay, and the top on the bottom, that is also true. But I like to just think top to bottom. But again, you can flip the proportion and that will be an equivalent proportion. So these two segments, their ratios are similar, okay? Let's go ahead and apply it and see what that is all about. So here we have a triangle and we see that we have two parallel lines here, okay? So we have the side splitter theorem at play. So we know the ratio of this top two segments to their corresponding bottom segments are going to be equal ratios. How can we set this up? Well, we can say the top segment to the bottom segment will be equal both on we can call this the left side of the triangle and the right side of the triangle. So the left side of the triangle and the right side, they're going to be equal proportions. Let's go ahead and input the values. So we have A in the top here, and we have A plus 4 in the bottom. On the right side, okay, so now we did the left side, now we're moving to the right side. We have 12 in the top, and we have 18 in the bottom. What we do from here is we simply cross multiply and solve for A. So we have 18A equals 12 times A plus 4. We need to distribute here, so we have 18A equals 12A plus 48. We subtract 12A. You want to get the A's together, the variables together if they're on both sides of the equal sign. Equals 48, and we divide by 6 to finish this off. We get A equals 8. 8 times 6 is 64, so we have A equals 8. Now we could find the two segment lengths, and that's 8. And this whole green segment right here, oops, I want it to look like this. Take a look. It's worth it. Hang in there. There we go. Look at that. Beautiful. And we have 8 plus 4. That's going to be 12. Now, is the ratio of 8 over 12 equal to 12 over 18? Okay. We know this is equal to, we divide this, and it is equal to 0.67. If we do this, this is equal to 0.67, okay? 2 over 3 is equal to 2 over 3. So we have equivalent ratios on both sides. That's the whole point. When we have two parallel lines, essentially the reason for this is because these are going to be equal angles. These are going to be equal angles. So really what we got going on here with side splitter theorem is we have two similar triangles. We have this top triangle similar to this big triangle right here, okay, because of AA similarity. That's why the proportions of the sides are equal with the side splitter theorem, okay? That's just a reason why. I want you to understand why this works. Okay, example 2. We have parallel lines here. So guess what? We have two similar triangles at play here. We have this triangle here, and we have this big triangle here. You don't need to know that if you already understand the side splitter theorem. I just wanted to kind of highlight that information. We have this top part is going to be equal to the proportion of the bottom part. Okay, so then we can say 12 over x plus 1 is equal to 9 over x. Okay, and then we just cross multiply again. And we get 9 times x plus 1. Don't forget to leave in parentheses because we need to distribute. And we distribute next. Let's take this over here. 9x plus 9 equals 12x. We're going to subtract 9x. That's what you do when x or a variable is on both sides. We get 9 equals 3x. And we get x equals 3. So then we could find that side length. That would be 4. And this one would be 3. And both of those green segments would be 1/3 of the top segment. So we have equal proportions on both sides. Here's a corollary. That means like an additional theorem for the side splitter theorem. If we have 3 sets of parallel lines through 2 transversals like this, 2 transversals, and then you can see we have 3 parallel lines here. We're going to have more angles that are all congruent because of corresponding angles theorem. Oops, sorry, we don't know if those are equal. Okay, so with that in mind, we can make another statement, and that's something very similar to what we already talked about. We can say that AB over, I want to use the same green, sorry, being picky here. AB over BC is the same as WX over XY. So AB over, let me just get this set up. AB over BC is the same as WX over XY. So you can see that it's like the top part over the bottom part. So it's the same deal. It's just not in a triangle this time, okay? But it's same principles apply. Let's apply this to kind of like a real world situation. Here we have a campsite, and we know because it says campsite here. And we have 3 different campsites with different measurements. We have this campsite, 8 yard. Oh, this is supposed to be water. I forgot to add in the water. Let me add that in for you. Make this a little bit more valuable of a waterfront. Okay, so we have some water. Now it's way cooler campsite. Okay, what do we have going on? We're looking for x, so we need to set up a true proportion with x. Well, we could say, if we kind of twisted this whole thing, if you want to turn your screen, you can see that this top part is going to be proportionate to this bottom part. This is the same thing as the corollary to the side splitter theorem. We have parallel lines, parallel lines, parallel lines, parallel lines, okay? So this blue part, which is 9 over 7.2, is going to be equal to x, this other top part, over its corresponding shoreline, which is 8. So here we could call this even the bottom of the shape, okay, the bottom of the campsite over, oh, sorry, that's not the bottom, is it? We could call that, I don't know what to call that. We can call that the left side, I guess. We'll call that the left side because you can see that the blue is on the left side there. We can call that the left side over the right side. Okay, so on the left, this was the shore. Okay, sorry, here's the shore, the x over the, oh no, that's not the shore, is it? The shore is over here. My apologies. The shore is over on this side. So the x and the 8 are both part of the shore, and this is both part of the bottom of the, not that you need to know that, I just kind of wanted to label, see that I keep the x and the 9 together on the right side, and then the 8 and the 7.2 on the left side of the proportion. Or, sorry. I did the 9 and the 7. There, here we go. The bottom part is together. Sorry, I got myself a little confused. And then the top part is together on the right side, okay? And then the blue goes together. The left side, the blue, is on the top. And then the green, okay, is on the bottom. I kind of wish I would have set this up differently. But as long as you're consistent on both sides, that's the important thing. And now we can cross multiply. We get 72 equals 7.2x. We divide by 7.2. And we're going to get x equals 10. And that makes sense because this blue segment here was bigger than its corresponding green part. So this blue segment here, x, needs to be bigger than its corresponding green part, the shoreline. So 10 is bigger than 8. That's how we kind of can check our answer. We have 2 more things to talk about. We have the triangle angle bisector theorem. We're given that AD bisects CAB. Okay, so we're going to have a very similar situation. We're going to have that, ooh, that's too thick. We're going to have this segment here, CA, compared to CD is going to be equal to AB over DB. Okay, so let me go ahead and write that out. We can say the top part over the bottom part. So that's CA over the CD is equal to AB over DB. Okay. Now, what's also true that you need to consider is that we can have, okay, the blue to the green, top of the bottom, but we could also compare the two blue sides to each other. So we could say, because we did here, this is what, the left side and this is the right side. We could compare the left to right side on the top and bottom, and then we can compare the top on the left and the bottom on the right. And let me show you what that looks like. See how I just kind of flipped this around a little bit? Personally, I like this, but I'm just saying you can make other equivalent proportions. If this is too much information, you don't want to understand that, that's fine. Just stick with this and then skip what I'm about to talk about. But technically, we could do this. So we could put the top part, so the left to the right. So the left part of this is CA. The right part is AB. Okay, so I'm comparing the left to the right. Okay, and then I can set this equal to the bottom part. So I could say the left part of the bottom, the green, is CD, and the right part on the right is DB. This is also true. So both of these are equal. If you cross multiply and solve for a variable, both of these will work. Both are valid, okay? So let's go ahead and apply it here. I'm guessing you guys like the first one I talked about, okay, where we had the blue on the two sides of the triangle, and we're going to compare it to the green. Okay, so we're going to compare left to right side. We have we'll call this our left side, we'll call this our right side. So left side, right side, and we'll compare, actually the green is the top now, so we're going to compare the top to the bottom of this triangle. Okay, so the top part here is 10 over the bottom part is 12. Okay, again, there's multiple ways to do this. This is the way I'm showing. Then we have the right side. This is the right side. And then we have 18 over the bottom part, which is x. And that's what we're looking for. So we simply cross multiply like we've been doing. Okay, this is going to become your new best friend. And then we have 12 times 18. Let me get some help here. 12 times 18. We have 216. So I divide by 10, and I get x equals 21.6. Final answer. That is my value for x. Hopefully you found this helpful and this was a good extension of what you've been learning out with the proportions. Thanks for watching. Hope to see you next time.